Hello friends, welcome to our channel. Let's look at this problem, partition labels. This problem is very typical, so it can be categorized as interval merge type problem, or we can use chain chasing method to solve it. So in this video, our plan will be the following. We provide three solutions. So one is with sorting and for interval merge, and the second one will be without sorting for interval merge. And the third solution will be chain chasing. With that said, let me first state the problem requirements. So here we are given a string, and we want to partition the string into as many parts as possible. So here is as many parts, right? Not as less parts as possible. So the requirement is that each letter appears in at most one part, right? So here is an example. If one part you include A, you need to include all the A's, but you have already included B, you need to also include all the B's. So one part will be AB and AB. Then the second part will be C and C. So that's the problem requirement. So we want to return a list of integers representing the size of these parts. So overall, we want to partition the original string into some substrings, and the strings satisfy this condition, right? Each letter appears in at most one part. So here is example 1. The return will be 978. So actually, if you look at the starts and ends of the letters, for example, A starts at index 0 and ends at index 8, right? So you need to, this is the corresponding interval. So, and B is this, like a 1 and 5, right? This is the corresponding B, and so on. Then actually the first interval will be the ones you can merge, right? So for example, 0, 8 has overlapped with 1, 5. We need to merge to have 0 and 8. And then also have overlapped with 4, 7. So we need to have 0 up to 8, right? So this is the first one. So the length is none. So similarly, you can look at this one, 9 up to 14, and this one, and this one, and this one. So they actually overlapped. So the merged interval will be the smallest start will be 9, and the largest end will be 15, right? So you get 9, 15. So similarly for the last one. So that's why you get 8 minus 0 plus 1, that is 9. 15 minus 9 plus 1, that is 7. And 23 minus 16 plus 1, that will be 8. So this will be the return. Therefore, if we can get the starts and ends of the unique characters, and then starts means start index, and ends means end indices for the unique characters, then we can do interval merge, and then we get the return. So this is the main major idea for interval merge type, right? So I guess if you are able to realize this pattern, doing the coding would be rather straightforward now. So first, we are going to write a solution that with some details, or with some interval merge v1, so with some redundancy, also with sorting. So the reason we do this is to understand the final details, because the principle, the guiding principle will be, if you do not understand the detail, you cannot control it, right? You cannot control it. So if we want to write succinct code, we need to understand the details. So this is the process I want to demonstrate to you. So here I'm going to have a starts, right? It's a dictionary, and the ends is going to be a dictionary. And then I'm going to iterate. So for I and the character in enumerator S, right? So if character not in start, and then we can set this character so to be I, right? If it were in the start, so we shouldn't update that. But for ends, it's different. So we need to always update that so that we can get the last indices for characters. So actually, you can print out this starts and print out this ends just for comparison, right? So you get A0815. Yeah, you can compare this 0815, right? So with that done, now let me delete this part. So we can get the intervals, right? The intervals. So here, basically for key in starts. So what I want to do is I want to append to the intervals. Append. So basically starts of this key and ends of this key, right? So we need to sort it, right? Because for keys it randomly pass that. So now before we run that, we need to do some print. So print intervals. You're going to get 081547 914 like this one, right? So now I guess the problem will be very standard, right? Merge interval. So because we have sorted it, right? So the starts will be in the increasing order. So then the merging would be rather straightforward. So here I can use a stack explicitly just to demonstrate to you the procedure. In reality, you don't need to explicitly using a stack. So that's the first one. And also the way we write, we first put the first interval into the stack. This will always make the stack non-empty. It brings us lots of convenience, you'll see. So now let's iterate. So for I in range, so we start from 1 and ending at the length of the intervals, right? So now what we do, we have the previous end and start and end will be stack the top element, right? Then the current S current and the E current will be intervals I, right? So now we want to check if there is overlap. So if S current is greater than E previous, right? There's no overlap. So what we do, we just need to append the current interval. That is actually you can just let me write S current and E current just to compare with the other case. So if this not the case, then the previous interval and the current interval have an overlap. Then what we do, we first pop the previous interval, and then we append or put the current the merged interval into the stack top. So if we want to find the smaller start, that will be S and score, because this is sorted. And then we want to find the max of E previous one and E current, right? So this way we finish the interval merge, right? So now what we want to do is to do the return. So we return the length, that is element at 1 minus element at 0 plus 1. So for element in stack. So before we make comments, let's first do a test. Yeah, it passes the two test cases. Now let's look at the generic case. Yeah, it passes the generic case very fast. Now what we want to do, I want to print out this. Print out the stack, because this stack contains the merged intervals afterwards. So if we run it, and for this one, this is the merged interval. So you get 9, 7, and 8 in length, right? So similar, you can look at example 2, has just 1, right? So the length is 10. So this is the first solution. But here we use the sort, though it's still fast, but the time complexity is not good, because sorting is O n logarithm n, right? And n is the length of this intervals. So now let me copy this part. I want to copy up to this part. Let's see if I need this. Yes, so I copy it up to this part. And then I will put it here. I'm going to change this one to be version v1. So the version v1 is for digestion and for details. This can be important actually, right? So this one will be version v2, so without the need of sorting. So here again, I get the starts and ends as before. Then I can directly write the result, and I just want to put things in front. So here the result, what I want to put is, so the starts at S0, so the corresponding character. This is the one, and the ends at S0, right? So this is a tuple, so I can add it here, right? So now with that done, it's, this result actually plays the role of the stack here, right? So now why this way we don't need to do sorting? That's the for loop, right? So for I in range 1 to length s, so I iterate over this length, the string. So then we get the previous start and end. It will be this. It will be result -1, the top element in the result. And then the S current and the E current, it would be this. It will be starts SI and ends SI, right? I directly retrieve the corresponding intervals. Therefore, I don't need to do sorting, right? But there's a difference, because here I'm iterating over a length, roughly the interval length. But here I'm iterating over the length of S. That's the difference, right? Once we have this, we need to check if we have overlap. If S current is strictly larger than the E previous, so there's no overlap. So what we are going to do is we append S current and S E current. This is the one. Otherwise, there will be overlap. So we're going to do result pop. Yeah, this is the parallel in the stack, right? So now what we want to do is append the merged interval. The merged interval will be S previous and max of E previous and E current. So here, please avoid using S, because S is also the string, right? That's why I use S underscore. So once we have this, and then actually we can do return. So E1 minus E0 plus 1 for E in a result. So before we make comments, let's first run it. Yeah, it passes the two cases. Now let's look at the generic case. Yeah, it passes all the cases. So here, I guess it's good to do some analysis of temp complexity, right? So here, for getting the starts and end, so this will be O of n. So let's assume n is the length of this S, and m will be the length of the intervals, right, we get. So essentially m will be the equal to the number of unique characters, right? So now let's see. So this part from the start up to line 40, this will be O of n. And then you plus this one. Here you did a sort. So if you do a sort, it will be O m logarithm m. And then here you do a linear, right? Linear scheme. It will be O of m. And then you just return. It's also O linear, right? The length of the stack, but let's ignore that part. So this yields O n plus m logarithm m, because we can drop the linear term. So this is the version v1. For version v2, actually it's still different, right? So we have on, right? Then we don't have the sort, and then we iterate again over this string, and then this is O of n. So overall it will be O of n, right? So I guess that's the time complexity for the second version. So with that said, I guess we are ready to write the third solution. So let's call this one version v2. So the third solution will be chain chasing. So this is exactly what we do in a intuitively, right? So here you have A, and then use last index, you need to include all those. But now you have B, you need to include all the B's up to the last occurrence. So that's the chain chasing. So here, let me first write down the coding. And coding explains the algorithm. So let me get the last thing. So it will be character I. For I character in enumerate S, right? So here I can write this because some of the keys might be the same. Then because here is a linear scan, it will be get updated. So the result of this will be for each character you get the last indices corresponding to the ends in the first two versions of solutions. So now let's look at so essentially it's a two-pointer. Let me have J is 0, right? The start. J is the iterative one. Start will be 0, and the result, let me put here the result. And then what we are going to do is for I character in enumerate S. So what we do is we find the J, the max, so we can see from the current index character what the the furthest position we can arrive. First is the J, current J, and then last thing, right? So what's the last index? We need to include that, right? So then the thing is if I equals J, meaning that, oh, here I need to, from A, I need to at least here, but when I iterate B, I need to at least here. So when you 0, 1, 2, 3, at index 3, so there's two matches. So if you are matching, so what you do, you append. So this forms one block. So the end will be J, the start will be start, and then you increment by 1, right? Then you reset the start to be J plus 1, and not I plus 1. You can write J plus 1, it's the same. But writing I plus 1 is logically more clear. In the ultimate sense, they are the same, right? So we just need to return a result. So this is the third solution. So we are using chain chasing, right? It passes the cases. Now let's submit. It also fast. So now if you look at the time complexity, so because here you are going to iterate, this will be O of n. N is the length of S. And here you are going to iterate again. So in the worst case, it's still O of n. So the time complexity will be O of n, right? So space complexity also O of n due to this last thing, right? So with that said, I guess we finished the coding part. So now again, let me come back to the beginning and then make some comments or summary. The first comment is that here we provided 3 formats of solutions, two based on interval merge, and the other based on chain chasing. So this is the first comment. The second comment is that if we want to do short code or even we do better coding, we need to understand the details, right? So this is the second comment. So the last comment is that we have a playlist for interval merge type problem in our channel. You're welcome to check out those videos. The more you practice, the more familiar you are with this techniques or method. With that said, that's it. Thank you for watching.